right, well today I want to talk about mean value theorem and Rolle's theorem. We have a couple theorems we're going to talk about that basically help us develop some ideas about continuity and values of continuity and values of a derivative between 2 points, things like that. So let's discuss the mean value theorem first. If f is continuous on the closed interval a to b and differentiable on the open interval a to b, then there exists a number c in a to b such that f prime of c is equal to f of b minus f of a over b minus a. All right, well, what's that really mean? Let's draw a graph. Let's see what this looks like. If we have a function looks like this, right? And we've got a point A, and we've got a point B. Okay. All right, so here's B, here's A. And if this is differentiable, then there must be a point C between them, right, here, where the value of C is going to be equal to that value of between f of b and f of a, right? So that this point is going to be equal to this value right here, okay? These lines are parallel. That's all it says. An instantaneous rate of change is equal to an average rate of change, okay? So the instantaneous rate of change is equal to the average rate of change. And the tangent line is parallel to the secant line. This is our tangent line, we know that. Secant line goes between these 2 points here. That's it. That's all we're talking about. All right, so let's discuss a little bit further something else. Rolle's theorem. Well, Rolle's theorem says, let f be continuous on the closed interval a to b and differentiable on the open interval a to b. If f of a is equal to f of b, then there exists at least one number c in a to b where f prime of c is equal to 0. Okay, so that's a little bit different. Let's draw that graphically. All right, if we've got a graph, we've got something here, and let's say that this point here, this is a, and this is b, okay? And these are equal to one another, right? They're equal to one another. So a is equal to b, f of a is equal to f of b. C, there must be a point C where the slope of that tangent line is equal to 0, right? Basically, there has to be a minimum or a maximum in between there if we have f of a equal to f of b. Something's got to go on. It's going to come up. It's going to come back down at some point in time. Or maybe it's just going to stay straight, you know, if you had just a linear function. But at least one number between a and b, so it would be horizontal. Now, could it be more than one number? Yes, certainly. If you had a point A and a point B, and you had something, I probably should have drawn the graph first, you know, you could have that, right? Let's say that a and b are exactly the same. You can have multiple points in here where your derivative is going to be equal to 0, but it does exist, okay? At least one. All right, so let's actually do some practice here. So let f of x let f be the function given by f of x is equal to x squared plus 2x minus 3. We want to find the number c that satisfies the conclusion of Rolle's theorem for f on -3, 1. Well, first of all, I'm going to go flip back here. We have to decide a few things here. Is it continuous and is it differentiable? I'm going to do that. So is this function continuous? Well, it looks like it's just a parabola, so yes, that's continuous. And is it differentiable? Yes, that's differentiable. Okay, those first two things are satisfied. So then we have to determine, is f of -3 equal to f of 1? Well, f of -3 is going to be 9 minus 6 minus 3, which equals, what, 3 minus 3 is 0. Okay, and f of 1 is going to be 1 plus 2 minus 3, which equals 0. So f of -3 is equal to f of 1. Okay, they both equal 0. Great, we know that that works. Well, now we know that we must have a point where the derivative is equal to 0. Well, where is that? So we're going to take f prime of x is equal to 2x plus 2. Then we're just going to set that equal to 0. So 2x is equal to -1. So, oh, not -1. What am I doing? It's equal to -2, and x is equal to -1, right? So what's that value c? What's the number c that satisfies this conclusion? Well, c, therefore, c is equal to -1. Okay, that's our final answer. the value between f of negative 3 and f of 1, where the slope is equal to 0, is negative 1. And because this is a parabola, this is probably our vertex there, right? Okay, let's do another one. This one has to go with our mean value theorem. A sports car speedometer registers 50 miles per hour as it passes a mileage marker. 4 minutes later, the car passes a marker that is 5 miles from the first, and the speedometer registers 55 miles per hour. Can you use the mean value theorem to prove that the velocity of the sports car was more than 70 miles per hour at some point between the two mileage markers? Okay, so let's say we've got, here's our car, it's going, woo, fast. And we've got our first mileage marker here at point A, and we've got our second mileage marker here at point B. We're going in that direction, right? So t here is equal to 0, right? And then 4 minutes later, t is going to be equal to 4 of 60, which is 1/15 of an hour, right? Because we're talking about miles per hour here, so we want this to be in hours. So here, t is equal to 1/15. Okay? So far, so good? Okay. And then our distance from the first marker at time t is our s of t. Okay? So s of t is our distance in miles from the first marker, so from the first marker, or you could just say point A in time t, okay? That's what our distance is right there, okay? So what is, how can we prove that at some point between the two mileage markers, our mean value theorem was more than 70 miles per hour? Well, we can take the velocity of our average velocity, right? So that's going to be s of 1/15 minus s of 0 over 1/15 minus 0, right? Well, at s of 1/15, we don't have a function here, but we were actually given that. 4 minutes later, well, that was our time, 4 minutes later, 5 miles, this is what I'm looking for, 5 miles from the first. So that's going to be equal to 5 minus 0, right? When we started, we were at 0, over 1/15 minus 0. So that's going to be equal to 5 over 1/15, which of course equals 5 times 15, which equals 75 miles per hour. I don't know why I keep doing this. Miles per hour is written as mph. Okay, so if this is 75 miles per hour, we have proved that at some point in time, if our average, the average is 75 miles per hour, right? So the average velocity is 75 miles per hour. Therefore, the car must be going 75 miles per hour, so the velocity must be 70 miles per hour when speeding up from, I guess, 0 or point A, 0 miles per hour, or point A, whatever you want to say, right? So at some point in time, because of our mean value theorem, we were going 70 miles per hour with our velocity, right? All right, so let's do 2 more examples here, and then we'll kind of wrap it up. We want to find all the values between the x-intercepts for which Rolle's theorem holds for the roots of f of x equals 4x squared minus x to the 4th. And, ooh, we were told to verify this with our calculator. Okay, let's take a moment here. Okay, so the roots of f of x equals 4x squared minus x to the 4th. The first thing we have to do is actually find out what these roots are. So we're going to say that f of x is equal to 4x squared minus x to the 4th, and I'm setting that equal to 0. So I have x squared times 4 minus x squared equals 0. I probably should have taken that out as a negative x squared. Let's do that. That'll be easier. So now I have negative x squared times x squared minus 4 equals 0. Negative x squared times x plus 2 minus 2 equals 0. So x can equal 0 2, negative 2. These are our roots, okay? And then we want to find what values between these roots are going to hold for Rolle's theorem, right? We know that these are all equal. These are all, when x is equal to 0, 2, and negative 2, we know that f of x is equal to 0. We just solved that. So we need to find our derivative. So f prime of x is equal to 8x minus 4x cubed. Oh, it's so deliciously disgusting. Okay, so we're going to take out a negative 4x. So we're left with negative 2 plus x squared, right? I'm going to rewrite that. So I get negative 4x times x squared minus 2. And I need to set this equal to 0, right? Because we're trying to find what values are going to have a slope of 0 between our roots here for Rolle's theorem. So x could be equal to 0, or x could be equal to plus or minus 2. I'm not going to do that math there. I think you know that it works. These are actually critical numbers. I just messed up the cramlet there. These are critical numbers, right? When something's happening, we're going to change from negative to positive, positive to negative. So our conclusion is that Rolle's theorem holds for x equals 0, radical 2, and negative radical 2 between the x-intercepts of f of x, which are equal to 0, 2, and negative 2. All right? Good? I didn't write this last part very well, but I think you get the idea. Okay, let's do our last one. We want to determine, oh, I forgot, we were going to check this graphically. Okay, calculator, let's just graph it. We'll graph it, we'll look at it. So we've got 4x squared minus x to the 4th. I wrote 4 to the 4th. That's not going to be any good to us. Okay, minus x to the 4th. Hopefully this is a little bit prettier. Oh, it definitely is. A nice little m there. Right? So if we trace this, if I trace 0, we're at 0, 0. We trace negative 2, we're at 0. We trace 2, we're at 0. Good. And if we trace negative radical 2, look at that. There it is. And we could find our slope there. We could calculate our slope. Calculate dy of dx at negative radical 2. It should be, well, it's equal to 5.6569 e to the negative 6. That's basically 0, right? That's basically 0. And we could do the same. So anyway, that works. We did it. All right. Last one here. Determine whether g of x is equal to sine of 2x plus 2x satisfies the hypotheses of the mean value theorem on the interval 0 to pi. If so, find all numbers C in A to B such that f of b minus f of a is equal to f prime of c times b minus a. Okay, first thing that we need to do is what? All right, first thing we have to decide is this continuous? Yes. Is it differentiable? Yes. All right, so that works. The next thing that we're going to do is find this value c between 0 and pi that satisfies this, right? So we're going to find g prime of x. So g prime of x is going to be equal to, derivative of sine is cosine, derivative of 2x is 2. So we have 2 cosine of 2x plus derivative of 2x is just 2. All right? And then we're going to we want to find this, f of b minus f of a equals f prime of c times b minus a. Okay, 1 second here. All right, so now we're going to need to find our average rate of change from 0 to pi. So we need to determine what g of 0 is. So g of 0 is equal to sine of 0 plus 0, which equals 0. Okay, and then we have to find g of pi, which is the sine of 2 pi plus 2 pi, which equals 2 pi. Okay, so now we're going to find this average rate of change here. So we will have 2 pi minus 0 over pi minus 0 is equal to 2 pi over pi, which just equals 2. And this should be equal to, right? So that is that f of b minus f of a should be equal to, and actually, if I rewrote this, f of b minus f of a over b minus a is equal to f prime of c, right? Well, what's f prime of c? Well, it's here. So this should be set equal to 2 cosine of 2x plus 2. Or I could rewrite this as 2 is equal to 2 times cosine of 2x plus 1. Okay? So I divide by 2. I get 1 is equal to the cosine of 2x plus 1. I subtract. I get the cosine of 2x is equal to 0. So now I have that 2x could be equal to, well, when is cosine 0? It's equal to 0 at 0. Pi. 2 pi and 3 pi. And I wonder if right now you're thinking, but Miss Brady, this only goes from 0 to pi. Why'd you do this? Well, here I have 2x, so I'm actually not done solving. And if I divide everything by 2, I'm going to get my x values could be equal to 0. Pi over 2. Pi and 3 pi over 2. And these, well, 3 pi over 2 does not actually, but the rest fall within our value from, or our interval from 0 to pi. So the numbers in A to B that are equal to this average rate of change equal to the instantaneous rate of change are 0, pi over 2, and pi. Okay, hopefully all of that made sense. If you have questions, leave them in the comments. I will see you in class. Bye!